Hey everyone, welcome to your play posit for the week. You might notice I changed it up a little. I was getting kind of bored with the old backgrounds, and I was like, ooh, this looks calming and soothing. So we'll enjoy a different color palette for this week. Today, we are going to go over multiplying polynomials and the difference of two squares. I kept the A for algebra. All right. So, multiplying polynomials. You may have heard of the term FOIL, and maybe you didn't. Regardless, I'm going to tell you a little bit about FOIL and how it relates to multiplying. This is what we'll typically see when we're talking about multiplying polynomials. And you can see we have a binomial times a binomial. So we see parentheses, right? And we think distribution. So it really is the same thing as distribution. You can use distribution or the FOIL method. So I'm going to show you distribution first. So that means you're going to take each of these terms and multiply it by everything on the inside over here. So we're going to go 2n times 6, and I'll write it all out so you can see each term, and then 2n times 1. And, oops, hold on. I put a plus there because there's a plus here, right? And then we're going to do the second term, 2 times 6n and 2 times 1. So each term in the first binomial, you have to distribute to the second. And then you just simplify. So 2 times 6 is 12, and n times n is n squared. We know that when we multiply variables, we add the exponents. So 1 plus 1 is 2. And then 2n times 1 is 2n. 2 times 6n is 12n. And 2 times 1 is 2. Then you'll just look to see if you can combine any like terms. These are like terms, right? They just have an n. So we'll have 14n plus 2. There we go. Look, we took this multiplying binomials and we expanded it. Why do I keep putting 11 to this? So multiplication and distribution, remember, is the opposite of factoring. So look, check it out. This is the factored form of this polynomial. Factored. Factored. Now let me show you the FOIL method. So the FOIL method, it's just an acronym, for first, outer, inner, and last. So it's just an acronym. It's just a way to sort of remember the steps. And what it means by first is you're going to multiply the terms that are in the first position. So 2n times 6n. All right, now we're going to take the two outside numbers, the very, very outside. So this one and this one. Those are the two outers. So 2n times 1. And then we'll take the inside numbers, the two inside terms. 2 times 6n. And then we'll do the last. We'll do this. The two numbers that are in the last position, 2 times 1. Now, if you're observant, you'll see we wrote the exact same polynomial as we did here, literally. So it just depends how you see it, how you want to remember it. If you're going to distribute each term, or you're going to remember this whole first, outer, inner, last. As you get quicker, better, you'll start to do this in your head. But I don't recommend doing that for a very long time. Practicing writing it all out is going to help you not mess up any signs or forget any variables. So let's try it. Pick your favorite method. I prefer distribution. We can talk about why in live class if you want. I have a very strong opinion about it, but I don't want to sway your opinion. So you can certainly choose one of the methods. So I'm going to distribute the first term to everything over here. So I have 6k times 5k plus 6k times 5. And then we'll take the second term. Sometimes I go like this to not mess up my lines. And distribute to everything inside. And 5 times 5. Now we just multiply. 6 times 5 is 30. K times k is k squared. We got another 30k. 5 times 5 is 25k and 25. Now we're going to combine like terms. You may start to see a pattern here, right? We're going to have a squared term. These are always going to combine, 55. And then we'll have a constant. So this is a trinomial. It's a quadratic because it's squared. Here, let's write that. It's a quadratic because the highest variable is squared. And it's a trinomial because it has 3 terms. So see, we took this polynomial and got it from this. You can see that the opposite of multiplying, or the opposite of distribution is factoring. So this is the factored form right here. So we're going to do a lot of going in between the two different forms, the expanded polynomial form and the factored form. Let's do it again. You might see it written like this. So whenever we see a squared, remember that means you write it twice. Like if we had x squared, we could write it twice. So here you write whatever the squared is on. So we write the whole thing twice, just like that. And now we can expand it. Again, you can use FOIL or distribution. We're going to do 4p times 4p. This is where you might be able to skip writing it all out. Okay, you're like 4 times 4 is 16. P times p is p squared. 4 times negative 1 is negative 4p. Now we'll do negative 1 times 4p and negative 1 times negative 1. And we'll combine those middle-like terms to get negative 8p plus 1. That's it. Here's another one. So now we have a binomial, 2 terms, times a trinomial. FOIL will not work on this. FOIL only works for binomial times binomial. So we're just going to distribute everything evenly. 7k times k squared, that's 7k cubed. 7k times negative 2k, negative 14k squared. 7k times 7 is 49. Now we'll do it with the second term. Negative 3 times k squared. Negative times a negative 2k, positive 6k, and negative 3 times 7. One of the parts that can be tricky about these problems is keeping your signs straight. So I make mistakes all the time doing this because sometimes I'm trying to go too fast, or I just naturally am going too fast. And so I'll just kind of mess up the sign. So be careful, double check your work. We have positive times all of these, so it should be positive, positive, and then negative, positive, negative. Okay. Now we can combine like terms. So we have that term in the front. Here's some squared terms. Negative 14 minus 3 is negative 17. Then we have our k term. I'm going in order, in descending order. And then we have our constant. For positive 49 minus 21. And you can always grab your calculator if you need to. And that is 28. And you're done. We expanded out these polynomials. I wanted to go back to the notes from last class that we didn't get to finish. This was the challenge that was put into the breakout rooms. It says to factor out the GCF. So remember, we're going to look at the coefficients first and see, well, what is the largest factor that they share? And we can write these out if you want. I'm guessing a lot of you are getting the hang of this where you kind of are already seeing that greatest common factor, but let's list them out for fun. 3 times 4, I think that's it, right? Yeah. And 12 is 1 times 12, 2 times 6, and oh, 3 times 4, that's not right. 3 times 8. There we go. Oh, yeah. And then 4 times 6. Anything else? 5. Nope. Okay. Now you're looking for the largest number or factor that all three of these have in common. I forgot 3 and 4. What am I doing? Oh, so it looks like it's 4. Even though 24 and 12 have a lot, only 4 shares the 4. And then we're going to look at the variables and see what do they all have in common. They all have an x in common, and they all have a y. It looks like we can only take out an xy because they don't. The lowest they have is that single term. So the GCF is 4xy. So we're going to divide each of these terms by 4xy and see what's left. So 4 divided by 4 goes away. There's one x and no y's. Minus 24 divided by 4 is 6. The x's go away, and there's one y. Plus 12 divided by 4 is 3, and these both go away. There we go. That's the challenge. You can check your notes from last class. And we're going to talk about special cases. So factoring the difference of squares. So remember the goal for factoring. When you factor something, you want it to look like this. Just like we saw here. Remember we talked about, let me get to that one example where I wrote it. Where is it? Here. This is the factored form. So we take that polynomial and we factor it. So that's our goal. So watch what's happening here. See if you can figure it out. See if you can figure out what I'm doing. There's that one. I'm going to do this one next. I don't have an answer key. I'm just doing this. I'm just doing it. Have you figured it out yet? These are a little different, but still the same. One more. Maybe you have figured it out. Maybe you're wondering, how in the world did she do that so fast? And you can do it the same. And I'm going to show you. Because the difference of two squares is very special. It has a special formula. If you ever have a binomial where you can write each of the terms as something squared and it's being subtracted, it's called difference, then you can always write it as a plus b, a minus b. Whatever those terms are, it's just plus and minus, and you're done. You've factored it. So let's try this. We have something squared. We have x squared minus, can we write 25 as something squared? Think about it. Grab your calculator if you need to. And you're probably thinking 5, right? Now look, this is A and this is B. So you just plug it into the formula. You literally just write x plus 5 and x minus 5. That's it. You're done. You factored it. And you can always check your work. Look, we can multiply this out, right? X times x is x squared. X times negative 5 5 times x, and 5 times -5. Ooh, these are x's, sorry. And then look, we're going to combine like terms. These cancel, and we get right back to where we came from. The beauty of mathematics. So again, if you can write it as something squared minus something squared, very technical term there, you can use this very special difference of squares formula where you just take the first term plus the second, and the first term minus the second. So let's try some. We're going to write each term as something squared. Now be careful, this has two values in it, so we need to write it as something squared. 2 squared is 4, and y squared is y squared. That works. And 9 is 3 squared. Now, this is our a and this is our b. So we just write 2y plus 3 and 2y minus 3. If you write it like this, that's totally fine. If you put the minus first, I just go by the formula. I always put the plus first. But these are exactly the same. Remember, multiplication is commutative. So you can put a times b and b times a. All right, let's do this one. 36 is 6 squared. So we have d plus 6 and d minus 6. Lastly, we can write this as 5y squared minus x squared. So we get 5y plus x and 5y minus x. Two more examples. So let's look at the first one. We're going to write this as something squared. So 2c squared minus 7 squared. Once you get these terms, it's pretty easy, right? You just take them, you add them together, and then you subtract them like that. And the last one, 5b squared. So a plus 5b and a minus 5b. That's it. Now, this only does work, though, for these very special cases. Two things being subtracted, and you have to be able to write them as something squared minus something squared. You did it. We did it. I will see you all in class this week, either Wednesday or Thursday. Please reach out if you need any help, and keep an eye out on your schedule. They're already there. Look for those what did I call them? 15 minutes of fun with Miss Winslow. Pop in if you want to say hi, see what some of your classmates are up to, or just kind of have a place to go. I will see you all next week.